Welcome back, and this is part 2 in this series about building blocks of geometry. In this video, we're going to talk about the distance axioms, the Triangle Inequality Theorem, and also what does it mean for points to be between? What is betweenness? Okay, so let's start with the distance axioms. There are 3, D1, D2, D3. And depending on the textbook that you're looking at, they may come in different order. We're just going to refer to these as D1, D2, and D3. And as long as you know what they mean, you can either refer to them in shorthand with their abbreviation, or you can write them out. And you can see that the shorthand really does come in handy. Okay, so the very first one, D1. D1 says, for each pair of points, A and B, D1 says, each pair of points, A and B, are associated with a unique, what does unique mean again? 1. A unique real number known as the distance between A and B, okay? If I measure between A and B are stationary, I'm going to get the same distance every time, okay? Now, units may change, but the distance is going to remain the same if the points stay in the same locations, okay? So one distance, okay? And we will abbreviate the distance between A and B as just AB with no other notation. Butt them up together like multiplying A times B, right? But there's no segment notation or line notation or anything like that, okay? And that's important because we're going to use that notation in the next axiom. The next axiom says, for all points A and B, the distance between them is 0 if and only if A is equal to B, okay? So the distance between A and B is equal to 0 only if A is equal to B. In other words, A is sitting right on top of B. Their locations are exactly the same. That's the only way the distance between them can be 0. All right. And then the last distance axiom, for all points A and B, AB is equal to BA. The distance between A and B is the same as the distance between B and A. That seems pretty obvious, right? If I go to Walmart, the distance is going to be the same if I come back from Walmart. Yeah, okay. All right, so, but let's just define that as one of the distance axioms. Okay, the next thing we're going to talk about now is the Triangle Inequality Theorem. Okay, the Triangle Inequality Theorem says, if I create a triangle, then if I add 2 of the sides of the triangle, and it doesn't matter which 2, any 2 sides of that triangle, if I add the distances between them, it has got to be greater than the length of the third side, okay? So let's look at that. If I've got something that looks like this, let's create a triangle here. Here I've got AB and BC and AC, all right? So in this case, I can say this distance A to B plus this distance B to C has got to be greater than this distance A to C. Okay, if it was not greater, it would not make a triangle. Okay, don't believe me? Try it. Oh, let's actually look at what would be true if they were equal. Okay, all right, if AB plus BC is equal to AC, you're going to end up with something that looks like this. A, B, C, all right? If AB plus BC is equal to AC, you kind of have a segment with a point in between the endpoints. Okay, so that actually is going to lead us into our next topic, and the next topic is, okay, so what does it mean for a point to be between 2 other points? We have a loose mental image of what that means, but in geometry, it means something very specific, okay? So in geometry, it means that if I've got any 3 points, A, B, and C, we say that B is actually between A and C if two conditions apply. First, A, B, and C have got to be distinct collinear points. Okay, what does that mean? Distinct means different. Okay, so A is not the same as B. They don't have the same location. B is not the same as C, etc. And collinear means they lie on the same line. All right, so A, B, and C are distinct collinear points, and the distance between AB plus the distance between BC is equal to the distance between AC. Okay, that's the only way that we consider a point to be between two other points. Now, this is a notation we use for B is between A and C. Okay, it's these little hyphens in between. Okay, and so that's just the notation. So B is between A and C. Okay, so betweenness. We talked about what does it mean, but now let's look at the betweenness theorem. The betweenness theorem says that if B is between A and C, we can also say that B is between C and A. That makes sense, right? But let's prove it, okay? Because not everything mathematically works that way. I mean, if you think about matrices, you can't actually multiply them in either direction and get the same result. So we need to actually look at things as if they're two separate things when we view them often as the same thing. Okay, now the second part of the betweenness theorem says, well, if B is between A and C, then I cannot say that A is between C and B or C is between A and B. Okay, because if the first is true, the other ones can't be true. We're going to prove this, and we're going to use outline proof in order to prove this, okay? So let's start by what are we given here? We're going to prove this theorem. We're given that B is between A and C. The first thing we want to prove, we're going to have to do kind of two parts because there's two parts of the theorem. The first thing we want to prove is B is between C and A. Okay, so let's start with what we're given. Write down the statement that you're given, and then the reason that we can write it down is because it's given to us, okay? So we can say for number one that B is between A and C, and that's because it's given. Okay, now, second thing that we can write that's going to come from this statement. What did we just say this means? Right? Do you remember from our definition? What does this mean? That means that points A, B, and C are collinear. They're distinct. And the distance from A to B plus the distance from B to C is equal to the distance from A to C. Yeah. A to B plus B to C equals A to C. Okay? Let's go there. All right? Okay, and why can we say that? We can say that because the definition of betweenness. We want to think about a proof with the end in mind, right? We want to get to B is between C and A, right? So let's go ahead and flip-flop the order that we're adding. We can do that because that's called the commutative property. Okay, we can say that BC plus AB is also equal to AC. Okay, so all we did was take these and flip the way we add them. And we know that that is true. We often just assume it to be true, but there's actually a name for that, and that's the commutative property. Okay, commutative property of addition. All right, now, do you remember what we talked about with distances? The distance from A to B is the same as the distance from B to A, right? And since these are distances, I can rearrange them. I can say that the distance from B to C is the same as the distance from C to B. So I just flip-flopped all the distances. And why can we say that? We can say that because of D3. Remember those distance axioms? D3 said that the distance from A to B is the same as the distance from B to A. All right, and then we're down to one step, right? Because now I can say, well, since this is true, we already knew that those were three distinct points and that they were collinear. We can now say that B is between C and A. And this, going from here to here, is again the definition of betweenness. Okay, so that's the first part of this proof. The second part of this proof is saying that, okay, if B is between A and C, then A cannot be between C and B, and C cannot be between A and B. Now, both of those are kind of the same thing. It's taking one of the endpoints and putting it in the middle, all right? So we're just going to focus on one because it could be rewritten the other way with the other letters, okay? And I'll show you how you actually say something like that in a proof, okay? So let's do the second part now. Okay, you ready to rock and roll here? We're going to start the same two steps, okay? So we're going to start by stating what's given, because it's given, and we're going to go that next step of definition of betweenness. Okay, so let's look at that. Okay, so we are saying now that B is between A and C because it's given. We're also saying that the distance from AB plus the distance to BC is equal to the distance from AC, and that's because of the definition of betweenness. This is where the proof is going to change. Because we're proving that C is between A and B is impossible, we're going to use a different technique. We want to prove something's not possible, so we're going to use proof by contradiction. Okay, and so we're going to assert that this is true and show that it can't work. Okay, so we're going to go ahead and say C is between A and B. Okay, so we are going to assume C is between A and B to be true. All right, and we just call that a contradiction assumption. All right, so if that's true, we can use that definition of betweenness again. So the distance from A to C plus the distance from C to B should equal the distance from A to B. And that's again the definition of betweenness. Okay, so if that's true, so we assume this to be true, and from that we said, okay, well that's true. All right, now we can use something we already said. We already said that AC is equal to AB plus BC. So I'm going to replace this AC right here with this AB plus BC. And we will call that substitution. Okay, so now I've replaced this. And can you kind of see what's going on here? Ooh, maybe you're able to see why this doesn't work out, right? Now what I can do is change this distance to the other one. Change CB to BC. We did that before. And we used D3 for that. Okay, so let's do that. Oh, can you see some things that are going on? We can combine like terms and we can subtract that AB from both sides. Okay, so that will end up looking like 2BC is equal to 0. So if twice the distance from B to C is 0, so that means from B to C has got to be equal to 0, right? And that's from division. And if B to C is equal to 0, then B has got to equal C. That's by D2. But that's not true, okay? And that's where the contradiction lies. Because up here, since we said that B is between A and C, that means they're distinct. That's part of it, okay? Okay, so now we said that B is equal to C by D2, and that is the contradiction. All right, so when we actually prove by contradiction, we assume that what we're trying to prove is impossible is possible, and we prove that there's going to be a contradiction somewhere. The very last line can just say by contradiction, A, C is between A and B is not possible, and we're out of room there. But we also use this little symbol to represent contradiction. So you can use that in your proof if you want. Then the other thing that we would want to probably do is, we did this one, we can say as a follow-up line, without loss of generality. WLOG is usually the abbreviation there. Without loss of generality, A cannot be between C and B because it's the same situation. It's just the other endpoint that I put between, okay? So that's your proof on betweenness, and it's a nice little proof to further illustrate what outline proof looks like. All right.